So in this tutorial what we're going to do is to take an image from ROS that was made with Gazebo using the engine of Gazebo. So in fact what you have to do first of all is go to your Catkin SRC and make the heat clone and clone our repository. And once you have done that, you do a cd catkin make. Okay, you click enter, and in this case I have everything built, so it's not going to take very long. But in fact what he is doing is checking all the packages that you have downloaded. In order to ease the execution of all the nodes for our environment, I have created a launcher in Python. So you go to src and then you say Python point launcher, and in fact what he does is to launch the ROS core and then opens a new terminal in which we have all the nodes that we're going to use. For example, here it's starting the Gazebo world, as you can see. In the other one it's starting the image, what you can see here finally, and the joystick and our controller. So in fact if we now I'm using a controller, so as you can see I'm changing the values of my controller. I'm able to move around my image. Okay, so this is working. Now regarding this is already explained in another tutorial, but now the new part is how to track the points of the cube. So once you have downloaded everything and installed the packages, we have built a package that is called the Visp from characteristics. And if you execute the, let me see exactly the name, so it's called image track ROS CCP. Okay, that's the source file. So if we execute the correct program, so you can see we're having exactly the same thing we saw before in the ROS topic image. This one here is in color, and in fact when we are using the blob detection, what we're doing is using blob detection and tracking. So we have it in white and black and white. So in this case what we have to do is to click in the different blobs we want to, as you can see, track. So I'm going to click in the 4 blobs of our image. As you can see, it has initialized perfectly the blobs, and now he is able to track them in real time. Okay, so the next step is to build the frame for these points. Okay, so what happens is if we are really far from the system or really close to it, and the points are not well detected, okay, they are lost, and that gives an exception in our program for the moment. Then we will try to manage the exception. So for example, now I'm getting really far. Okay, he is able to track the points, but at some time he's going to lose them. So in that case the system says there is an error and it has to close itself, but that will be fixed in the following weeks.